Hi everyone, this is Mrs. Torigno and this is page 6 of the Geometry C semester exam review packet. I'm starting here with problems number 20 and this video will probably just cover questions 20 through 23. Question 20 is asking about biconditional statements. It gives you a series of if-then statements and wants you to write them as biconditionals. Remember, a biconditional statement is a statement where it's true in both directions, okay? So the if-then is true, but then the converse of that would also be true. And as soon as you see the word biconditional, I want you to be thinking if and only if. Anytime you are writing a biconditional statement, I should see that phrase in there somewhere, okay? A biconditional statement uses if and only if in the middle of the statement, and it does not use the if and the then. So let's take a look at this first one. It says, if a figure is a triangle, then it has 3 sides. I would probably start by identifying my hypothesis and my conclusion in the statement the way that it is right now. Okay? Then I would cross off my if and my then, and I'm just going to string these 2 chunks together with if and only if in the middle. So I would say, a figure, and I'm going to abbreviate here a little bit, hopefully you can follow me, is a triangle if and only if it has 3 sides, which is my other underlined chunk piece here. If and only if it has 3 sides. Okay. A figure is a triangle if and only if it has 3 sides. Now we need to decide if that's true or false. And remember that in order for it to be true, it has to work in both directions. So, is it true that if a figure is a triangle, then it has to have 3 sides? Yes, that's true. That's the definition of a triangle. And is it true that if a figure has 3 sides, it has to be a triangle? That one's a little trickier to think about, but hopefully you'll see that that's true. That if it has 3 sides, there's nothing else it could be besides a triangle. So I would say that this statement is true. Okay. So for each one of these, we are going to write a biconditional and then say true or false. Okay. If 2 angles are supplementary, then 1 angle is obtuse. So once again, I'm going to identify the hypothesis and the conclusion. And remember, the hypothesis and the conclusion do not include the if and the then. The hypothesis comes after the if, and the conclusion comes after the then. And then I'm actually going to cross off the if and the then. Okay? And I'm going to take that magic phrase, that if and only if, and put it in the middle. So this would read, 2 angles are supplementary. I'm going to abbreviate supplementary. I hope you're okay with that. If and only if one angle is obtuse. Okay, well, let's think about that. So if you know 2 angles are supplementary, is it true that one of them has to be obtuse? And honestly, probably a lot of you will fall for that because in most cases that's true. Okay? In most cases, one of the angles would have to be obtuse in order for them to add up to 180. Because in order to add up to 180, you'll usually have one angle that's less than 90 and one angle that's more than 90. And that's how you get a sum of 180. But I want you to think about this right here. If I drew that so that I have a right angle here and a right angle here, each of those are 90 degrees, right? So those 2 angles are supplementary because they make a straight line, but neither one of them is obtuse because remember that obtuse means an angle that's bigger than 90. So that is the only way that this direction does not work, the if to the then. Okay? So this statement right now I can say is false, because in order to be true, it has to work in both directions. Now, if I wanted to, I could go ahead and figure it out in the opposite direction. Is it true that if one angle is obtuse, then the two angles are supplementary? And that's not true either. But really, as soon as you identify that one of the statements does not work, you can say that the statement is false. Okay. On to question 3. If a triangle is isosceles, there's my hypothesis, then it has two congruent sides. And we're going to ditch if and then and stick if and only if in the middle. So a triangle is isosceles if and only if it has two congruent sides. Okay. A triangle is isosceles if and only if it has two congruent sides. Well, if you know a triangle is isosceles, do you know that it has two congruent sides? Yes, I would say that's true, because that's the definition of an isosceles triangle. If you know it's isosceles, it has to have two congruent sides. Okay, so that way is true. Now let's go back the other direction. If I tell you a triangle has two congruent sides, does that mean it has to be isosceles? The answer to that is that it's true as well. Okay, because again, that's the definition of isosceles. You're going to find that anytime you're working with a definition of a word, where the statement just says what that word means, that biconditional will be true. Okay, so this one is true. Again, because if I know it's isosceles, then I know it has to have two congruent sides. And if I know it has two congruent sides, it has to be isosceles. Okay? Okay, last one of those. If two lines are parallel, then they never intersect. Cross off that, and we'll put if and only if in the middle. So, two lines are parallel. If and only if they never intersect. Okay, so now, true or false? So if we know two lines are parallel, then do we know they never intersect? Yeah, I would say that's a pretty safe assumption, because that's the definition of parallel, is if two lines are parallel, they can't possibly intersect. Be very careful coming back the other way on this one, though. If you know two lines don't intersect, they have to be parallel. And again, I can see a lot of students, and probably even a lot of adults, thinking that that would have to be true, because that's usually what we think of the word parallel. But we learned about another type of line in our class this year that don't intersect, but that are not parallel. Okay? Hopefully this word rings a bell. Skew lines. Skew lines are lines that don't point in the same direction, but because they're in different planes, they're never going to intersect. So it is possible that they would never intersect and not be parallel. So the converse here does not work. Going back in the other direction does not work. So I would say that this statement is false. And my counterexample would be skew lines. Okay. All right, that does it for biconditionals. And that actually does it for sort of the logic portion of your exam review. Now we're moving into a little more concrete geometry, which I know many of you will be very happy with. Okay. Questions 21 through 23 are all looking at this diagram of a cube here. And hopefully you can see it better on your paper. It looks like you can see the cube, but maybe not the letters, but that's okay. And it's just asking you to identify pairs of segments here. This is really just testing whether or not you know what these words mean. Okay? And we've talked a lot of times about how important vocabulary is in geometry. If I want two pairs of parallel segments, we did just sort of talk about this. Parallel segments are segments that never intersect, but they have to be pointing in the same direction. There's a lot of examples of that here. For example, these two here, AE and DH, those ones would be parallel, the ones over there on the left side. So I'm going to write those down, and I'm also going to make sure I use the correct symbol for segments. So AE and DH, there's one pair. Okay. Now I could use another pair that's going up and down, or I could even use pairs that go in another direction. So for example, right up front here I have HG, and then up above I have DC. So HG is parallel with DC. Okay. Now I just chose two pairs there. There's a lot of pairs you could choose from this diagram, but the key is you want to pick two segments that are going in the same direction. You could even say like AB and HG. You just want two segments that end up looking like this, or like, oh, it's hard for me to do with the camera there, but like this, or even on an angle like that. Okay? You just want two lines that are pointing in the exact same direction. Okay? 22, two pairs of perpendicular segments. Lots of questions in class today about what perpendicular means. Okay, so maybe study up on the meaning of that word, because that is going to pop up quite a few times. Perpendicular segments are segments that meet in a right angle. And you'll notice that because this is a cube, you've got a lot of right angles going on here. So we just want to list any two segments that make sort of that perfect corner, that right angle corner. Okay, so I just labeled one right here. AE and EH would work. Okay, so there's one pair that makes a right angle. I could even go over here and say AB and BF. That makes a nice L there. And again, there's a lot of other options here. There's a lot of things that, you know, would make that right angle. Anywhere where two segments meet at a corner would be fine for this diagram. If you have an answer and you're not sure if it's correct or not, go ahead and post it as a comment to this video, and I'll let you know whether or not it's correct. And that way everybody else can, you know, share from your new expertise. Okay, the last ones are skew segments, and those are the ones that I said might be a little bit harder to see. Skew segments are segments that never intersect, but they're also not parallel. They're not pointing in the same direction, and it's because they're in different planes. So you're really looking for two lines that point in different directions but don't intersect with one another. So I'm just going to start by looking at this GH here. Okay, and I'm going to extend, I'm going to try to extend GH. Okay, so pretend I took GH and extended it into a nice straight line like that. Okay. And then imagine I took this AE and extended it. And I know it looks in my diagram like these two lines are going to cross, but hopefully you can see that because this is a 3D drawing, that this segment up here is actually in front of this segment back here. And those ones are never going to intersect one another. Okay, you've got this one here, you've got this one behind it, and so those two segments are never going to cross. Now, of course, I've colored all over my picture and can't read the letters, but it looks like AE. That could be skew with GH. So again, segments that are going in different directions but aren't going to intersect. Okay, let's look at a different one, or a different pair. So for example, I could look at this segment BC here, okay, and then I could look at this segment DH. Do you see that this one and this one are never going to intersect because this segment is actually in front of this segment? So that would work too. And again, this is another one where there's tons of different options. So if you have one you're not sure about, feel free to post it and I'll let you know if you're right or wrong. Okay, so I could say DH and CB as my skew segments. Okay. Hopefully that's enough to point you in the right direction on those. Again, if you have any questions, feel free to ask in class or post as comments. And that's going to wrap it up for this video for tonight. Our next video will pick up with problem number 24. Thanks for watching and have a great night.